Good morning, this is Rachana, Assistant Professor of Mathematics, Institute of Aeronautical Engineering. In the last sessions, we have discussed only formation of a partial differential equation. Today, I am going to discuss about the solution of these partial differential equations. So, what are the types of solutions of these partial differential equations and all we have to discuss in this session. So, solution of partial differential equation, we have methods. So, first method is here Lagrange's method by grouping. So, what is the Lagrange's method and how we can get a solution of this partial differential equation and all we have to discuss in this session. So, generally, what are the partial differential equations? Dou z by dou x and dou z by dou y are dou square z by dou x square or dou square z by dou y square and all. Any equation involving these one, then we can have a partial differential equation. In the last session, we have discussed the formation of a partial differential equation from the given equation, which is of the form phi of u comma v equal to 0. If we eliminate this phi, we can get a partial differential equation of the form pp plus qq equal to r. So, what about p, q, r? These capital P, q are nothing but again a functions of x, y, z. Small p and small q already we know those are first order partial derivatives. So, capital P, pp plus qq equal to r. Nothing but partial differential equation, linear partial differential equation. Now, we have to take solution of this partial differential equation. So, how we can get a partial differential equation? So, in the last session, we have formed a partial differential equation from phi of u comma v equal to 0, which is the differential equation, partial differential equation. Now, here reverse. If suppose the given equation is a partial differential equation, we can find a solution. What is the solution of this partial differential equation? Reverse. We can get a from phi of u comma v equal to 0. Nothing but we have to find here two functions u and v. So already we know u is nothing but function of x, y, z. V also a function of x, y, z. So by using Lagrange's method, we will find the solution of this partial differential equation. So the solution will become phi of u comma v equal to 0 form. So here the equation of the form pp plus qq equal to r. This equation is known as Lagrange's equation, where capital P, Q are nothing but functions of x, y, z. So to solve this equation, it is enough to solve the subsidiary equations or Lagrange's auxiliary equations. What are the Lagrange's auxiliary equations or subsidiary equations? So we write that form dx by p, capital P. Here we have two notations, capital P and small p, capital Q and small q. What about small p and small q? Already we know those are partial derivatives with respect to x and y. Now here the subsidiary equations are auxiliary equations are nothing but dx by p, dy by q, dz by r. Capital R is also nothing but function of x, y, z. So dx by p equal to dy by q equal to dz by capital R. P, q, r is here nothing but functions of x, y, z. So here if we solve these three equations, these are the three equalities. So consider any two equalities, solve for solution u and v. If I'm taking u equal to a and v equal to b, these two are solutions of the given equation. Then the solution of the given Lagrange's equation is, which form is this? Phi of u comma v equal to 0. Write the two solutions of the form phi of u is the first solution, v is the second solution. Phi of u comma v equal to 0. Generally, the subsidiary equations can be solved in two ways. One is method of grouping and another one is method of multipliers. Grouping is nothing but we write the subsidiary equations of the form dx by p, dy by q, dz by r. Consider any two fractions, first and second or second or third or first and third. Consider any two we can get two solutions. One is u and another one is v. Then we write u and v of the form phi of u comma v equal to 0. So which will give the solution of the given partial differential equation of the form pp plus qq equal to r. In this session, we have to discuss about method of grouping. So what is the method of grouping and how we can solve this? First, whatever the given partial differential equation, you can separate p into p form plus q into q form plus r. P into p, capital P is nothing but function of x, y, z. Q into q, capital Q is nothing but function of x, y, z. pp plus qq equal to capital R. Here p, q are nothing but functions of x, y, z. Those terms here we have to write. So the subsidiary equations are dx by p, dy by q, dz by r. If the variables can be separated in any pair of equations, then we get a solutions of the form u equal to, let it be take a, and one more v equal to b. Sometimes we may get 3 also, but here we need only 2 solutions. Why? Because the solution of this linear partial differential equation is only phi of u comma v equal to 0. Here we need only 2 solutions. One is u and another one is v. So working rule to find the partial differential equation of the form pp plus qq equal to r. First take the auxiliary equation or subsidiary equations. What is auxiliary equation? Dx by p equal to dy by q equal to dz by r. First step to write auxiliary equation, that is dx by p equal to dy by q equal to dz by r. Whatever p, q, r, sometimes we have only x, y, sometimes y and z, sometimes x and z. Whatever it is, p, q are nothing but only x, y, z variables. So write the form dx by p, dy by q, dz by r form. Solve the subsidiary equations by the method of grouping or method of multipliers. In this session, we will find method of grouping using 2 equations, either 1, 2 or 2, 3 or 1, 9, 3. So for the first solution will become u equal to a and the second solution will get v equal to b. So the general solution will become phi of u comma v equal to 0. This is the process to find solution of the linear partial differential equation, which is of the form pp plus qq equal to r. Any equation having pp plus qq equal to r, we will follow this procedure. Now here we have one problem having px plus qy equal to z. What is first intention? We have to check that the given partial differential equation is linear or not. pp plus qq equal to r form is there or not? We have to check that. So capital P and capital Q are here nothing but small p into capital P plus small q into capital Q equal to capital R. What is capital R here? Z. Capital P is nothing but Y. Capital Q is nothing but X. So first take the given differential equation. Given partial differential equation is the standard form. That is pp plus qq equal to r. If not, we have to change that into given standard form. Now take the values. P equal to here x, q equal to y and r equal to z. The subsidiary equations are auxiliary equations are both the same. The subsidiary equations are nothing but dx by capital P, dy by q, dz by capital R. Now taking any 2 fractions we will consider. So I am taking, here we have dx by x and one more is dy by y and third one is dz by z. So we can consider any one of the 2 equations. So I am considering first and second one. Those are dx by x, dy by y. Integrating we get, so directly we can take integration. Here the variable is x, we will take the differentiation with respect to x only. So integration of 1 by x log x, integration of 1 by y log y. After integration we consider one arbitrary constant. So generally I am taking here log a. So take log y this side, log x minus log y. Log x minus log y is log of A minus log B. So nothing but log of A by B, which is equal to log A. Log x by y equal to log A. Both sides log cancel. We'll get x by y equal to A. So this is the first solution. So here we have one solution. Now we want to find one more solution. Take any one of the two equations. So I'm considering second and third one. So what is the second and third? Dy by y equal to dz by z. Now take the integration. So integration of 1 by y is log y. And integration of 1 by z is log z. Plus one arbitrary constant we have to consider. That is log b. Again, similarly take log z to that side. Log a minus log b is log of a by b. Nothing but log of y by z equal to log b. Both sides log cancel. Then we'll get y by z equal to b. So here we want only two solutions, A and B. If we take first and third, we'll get one more solution also. But here the general solution of the given partial differential equation is phi of u comma v equal to 0. So that's why we will find only two solutions. Now write the general solution. What is the general solution? Phi of u comma v equal to 0. We know nothing but a term here. What is a here? X by y. And b is here y by z. So which will give the general solution of the given partial differential equation of the form pp plus qq equal to r. Now here we have one more problem. Px plus qy equal to 0. Here we don't have r term. In place of r, here we have 0. pp plus qq equal to r. R is here 0. Now write the p, q and r terms first of all. So anyway, the given equation is in the standard form. pp plus qq equal to r is a standard form. Now what is small capital P, capital Q and capital R? Those terms first of all we have to write. What is small p? Dou z by dou x, and the small q is nothing but dou z by dou y. Capital P is x and the capital Q is y. And what about capital R here? Capital R is here 0. First of all, take the given equation is of the form pp plus qq equal to r. Then take capital P, Q, R values. Now consider the subsidiary equations. What are the subsidiary equations? Dx by P equal to dy by Q equal to dz by R. What is dx by P? P is nothing but x. dy by Q, y. dz by R. R is here 0. These are the subsidiary equations or auxiliary equations. Now consider any two equations from this. So I am considering first and second equalities. So dx by x equal to dy by y. Now take integration both sides. Integration of 1 by x is log x. Integration of 1 by y is log y. Plus some arbitrary constants we have to take after integration. That one I am taking log a. Similarly, take log y to this side. Log x minus log y is log of x by y, which is equal to log a. So again, log a minus log b is log of a by b. Both sides log cancel. We'll get x by y equal to a. This is the first solution of the given partial differential equation. We need one more equation. Consider any one of the two equations from this auxiliary equations. So I am considering same second and third equations. Second equation is dy by y. Third equation is dz by 0. Now if we take cross multiplication, we'll get dz equal to 0. After integration, we get z equal to b. Now the second solution is z equal to b. Now write the general solution, which is of the form phi of u comma v equal to 0. First solution here we have x by y, and the second solution is here z. So the general solution will give phi of u comma v equal to 0 form for the given partial differential equation of first order and first degree. Go for next one. Solve yzp plus xzq equal to xy. Whatever the given equation, first check that which is standard form or not. What is the standard form? The given equation is standard form is pp plus qq equal to r form or not. We have to check that first. So the given equation is already standard form. This is Lagrange's method. In this method, definitely the given equation is standard form, that is PP plus QQ equal to R form. Now consider what about capital P, capital Q and capital R. What is capital P here? Small p quotient is totally nothing but capital P, that is Y and Z. And capital Q is nothing but X, Z. And capital R is nothing but X, Y. So P, Q are nothing but functions of X, Y, Z, whatever it is. Sometimes division, multiplication, addition, whatever it is, but which is a function of X, Y, Z variables. Now write the next step, that is auxiliary equations. What are the auxiliary equations? Dx by P equal to dy by Q equal to dz by R. Dx by P, what is capital P here? Y, Z. Dy by Q, what is Q here? X, Z. Dz by R, what is capital R here? X, Y. So first step is check that the given equation is standard form or not. And the second step is write the subsidiary equations and consider from this any two equalities we can get easily integration. So like that we have to decide equations from these three equations. So now I am taking dx by yz and dy by xz. I am considering first two equalities. So dx by yz equal to dy by xz. So from this we can eliminate z. So here we are doing integration. So with the same variable only we can take the integration. Here z is another variable, but if we consider these two equations, z will cancel both sides. Then easily we can take the integration. So that's why consider first two equations and eliminate z and take the integration. Before that, cross multiply of these two equations, x dx and y dy. Now take the integration both sides. Integration of x is x squared by 2 and integration of y is y squared by 2 plus. After that we'll get definitely one arbitrary constant. You will consider either a or c1, c2, whatever it is. Anyway, those are arbitrary constants. Now I am taking x squared minus y squared. This denominator 2 also constant. If we take 2 into c1, we'll get c1 only. Anyway, constant is a constant. So that's why I am writing here only x squared minus y squared equal to some constant. That constant I am taking a. 2 into c1 will get another constant I am considering. That is a. So similarly, this is only one solution. Now we want to find one more solution to write the general solution. So that's why I am considering first and last term. The first term is here dx by yz and last term is dz by xy. Here we have another variable like dx by x should be there and dz by, if we consider, z should be there. But here we have one more independent variable, that is y. So both sides y cancel. Then we'll get easily integration. So here we have, if we take dx by z equal to dz by x after cancelling y terms. Take cross multiplication. So we cannot take directly integration here because dx by z is here and dz by x. So anyway, integration should be take with the same variables. That's why I am taking cross multiplication. X into dx and here z into dz. Now we can take simple integration. So already we know integration of x is x squared by 2 and integration of z is z squared by 2. After integration, definitely we consider one arbitrary constant, that is either c1, c2 or a and b. So in the first step we considered c1. So here also I am taking another arbitrary constant c2. Now what is the next step? Here 2 is a common. I am taking by z squared by 2 this side. X squared by 2 minus z squared by 2 equal to c2. Here LCM is 2. If we take 2 that side, we'll get 2c1. So then we'll get x squared minus z squared equal to 2 into c1. Nothing but I'm taking another constant b. So which will give the second solution. Or suppose if we want to consider second and third terms, dy by xz equal to dz by xy. here second and third equation. If we take second and third equation, we'll get another solution. So these solutions are which based on our convenient, we can consider any two solutions. Either consider first or second fraction, or second or third fraction, or first and third fraction. If we consider second and third, we'll get another solution. Why? Because here we have dy by z and dz by xy. Both sides x cancel and take cross multiplication. That is nothing but y dy equal to z dz. Here also we have same separate variables. So we can take directly integration. Integration of y become y square by 2 equal to z square by 2 plus some arbitrary constant c2. So if we consider first and third, we'll get x square minus z square. If we consider second and third, we'll get y square minus z square term. That is nothing but another solution. So based on our convenience and based on our fraction choosing, we can get the solutions of given partial differential equation. Anyway, the general solution will write phi of u comma v equal to 0. Anyway, u and v are functions of x, y, z. If we consider 1, 2 r, 2, 3 r, 1, 3. Anyway, we'll get same x, y, z functions. U is a x, y, z function. V also a function of x, y, z. So, I'm considering here first and third one. That's why I'm getting x dx equal to z dz. So, take the integration. Integration of x already we know x squared by 2 and z integration is z squared by 2 plus some arbitrary constant c2. So, here take 2 LCM, which is a common. I am taking 2 into C2. Nothing but we'll get x square minus z square equal to b. Now we write the general solution. What is the general solution? Independently, b is not a solution and independently, a is not a solution. Both combining a and b, nothing but u and b, two different functions. Write in the form phi of u comma v equal to 0, which will give the general solution of given partial differential equation. The given partial differential equation is linear partial differential equation. Then we'll get phi of u is the first solution, v is the second solution, or we can write phi of a comma b equal to 0. A and b are nothing but functions of x, y, z. So the general solution will give phi of u comma v equal to 0. So if we take second and third, we'll get another solution. If you want, you can consider third solution also. No problem. So for whatever it is, either consider 1, 2 or 2, 3 or 1, 3. We need two solutions. The two solutions must be functions of x, y, z variable. But sometimes we have only x, z variable. Sometimes we have x, y variable. Sometimes y, z variable. Based on the given problem, we'll get the solutions of partial differential equation. So first of all, here we have to remember the given equation is the standard form or not. If it is standard form, write the values of P, Q, R. Capital P, capital Q, capital R. P, Q are nothing but functions of x, y, z. Now write the auxiliary equation. The auxiliary equation is dx by P, dy by Q, dz by r. This is the standard form. After writing, check that if we consider for 1, 2 or 2, 3 or 1, 3, which will comfort to take the integration. If we consider 1 and 2, there is only variables are x and y. So like that we have to choose the fractions. If suppose we want to consider second and third are having y and z variable. The denominators also should be either y or z. Then only we can take the integration. If it is x, we cannot take the integration of variable x. So that's why we have to choose the equations either 1, 2 or 2, 3 or 1, 3. Based on that, we'll get two solutions. The first solution is nothing but u and the second solution is nothing but v. The general solution will write phi of u comma v equal to 0 form, which will give the complete solution. So if you find a, if you find b, there is if you find separately a and b, which will not give the solution. The complete solution will give phi of u comma v equal to 0. So this is the solution of given partial differential equation by taking method of grouping. This method is nothing but Lagrange's method. Find a solution of partial differential equation is nothing but Lagrange's method. Hope you all understood this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.